Alrighty.
Hello.
Mentally math!
Let's get mental.
Alright.
That was very energetic.
Okay, well let's get started then.
We made this especially for the kid that's gone.
Yeah, this is especially for the person who we're not going to necessarily name their name, but we are with you in spirit. We hope that your foot is feeling better.
What?
We are very concerned. Okay. We're not going into further detail on it on the internet. But anyway, our hearts are with you, my friend.
Yes. I forgot what the vortex is. Vertex is.
That's the pointy part. That's the pointy end.
I am stumped. What?
That's it. You can substitute vertex for corner, and it usually works. So you got an angle. You've got a part that opens up into space, and you've got a part that's pointy. The vertex is the pointy part.
Okay.
So.
Cool. Yeah.
Vertex.
Beautiful. Okay.
Okay. Okay, so I'm sure people are at least 3 into this by now,
I forgot the name.
or so.
Oh my God.
Rhetorical statement to passively say, please get to work. Okay, so the first one, we are dividing. Yes? What's D?
We can't see H.
Oh, here, let me bring that down. Oh, that's too far down. Okay, my bad. All right, so we are dividing negative 60 by a value of positive 3. So it's a negative end of positive, so that ends up being negative 20. Then, so for this, looks very scientific notation-y.
Awesome.
Which is what our lesson is about today. And so we would take our decimal and go, whoops, no, not like that. Yikes. Stop that. 1, 2, 3, 4, 5, 6. I'm gonna erase my little wavy line.
That looks so satisfying.
So that gets us 6,750,000. All right, then this is really just 2/3, right?
Yep.
So that makes m equal 20. And then, oops, and then I have this up here again. Sorry. Then I can say 10% of that is $12, and then add half of that to get me $18 bills.
Yeah, I couldn't confuse $120 for $12, so I got one.
Okay, then metric conversions. So there are 1,000 millis in a unit. So this would be 5/10 of a gram, otherwise known as half a gram.
Or a Grammy.
No. Okay, so this isn't your comedy club. Let's keep it professional here. Is this going to be worth stopping the lesson? Okay, great. Okay, so 24 divided by 3 would be 8, and then that times 8 would be 64. 24 divided by 3, I'm getting my unit, and then I'm multiplying that by 8. Give me 64. Then, so what you call angles that share a common side and a common vertex? Well, what they're getting at there is that those are next to each other. And if you're next to each other, like when I say you should only be working with someone who's next to you, like when we're doing our group work, when we're working on our problems. But I don't say next to you, I say something else.
Oh wait, I forgot.
Yes. Yes!
Oh, that's what it was.
Isn't that something in trigonometry?
Oh, that's what it
Like a side in trigonometry.
I thought it was, huh?
Adjacent.
Perfect.
Okay.
I'd adjust.
Good job. Okay, then at 60 miles an hour, how far will a car travel in 2.5 hours? So I just double that, 120, and then add another half of that to get me 150 miles. Yep. Don't understand which one? G. Well, it's saying, what do you call two angles that share the common side and a common vertex? So, maybe. Well, if. So those, a common side and a common vertex. So those are adjacent. Those are next to each other. Okay. All right, so multiplying numbers in scientific notation. This should be pretty quick and satisfying because we are just taking rules that we've already been practicing and just applying them. It should be no big deal. So we are taking these two expressions of scientific notation and multiplying them. Now, because of the commutative property of multiplication, we could just rewrite this like that, right?
Yeah.
And then maybe just slap a couple of parentheses signs here just for clarity. And so the first one I think is pretty self-explanatory. It's like 3 times 12 with the decimal in it to get us to 36. But then we put a decimal there, and that conveniently puts our decimal spot right where we need it for scientific notation, because scientific notation should always have one whole number on this side, and then everything after the decimal goes that way. Okay, then, and we're going to be going times, then 10 to the power of, and does anyone remember the rule where you've got the same number, but they have exponents? Okay, hold on. Room 16. No, other class.
Again, other question.
Wrong number, yes. Okay, anyway, back to this. Sorry, gentle viewers at home. All right, so you've got the same number, you've got exponents, you're multiplying them. There's a pretty simple rule for it.
Add the exponents of the multiplier?
Yes, if you're multiplying them, you add them together. And just to throw it out there, though it's not really part of this lesson, what if we were dividing? What would you do with those? Yes?
Let's subtract the exponents.
Yes, very nice. Okay, so that's our answer on this one. It's pretty straightforward, right? So the only thing they're doing to twist this one, well, a couple little twists with this one, but let's see if you can do this. They're giving us slightly different ways of expressing the idea of multiplication. The dot instead of the XC symbol. All right, so you try to figure this out first. Remember, there will be a little twist because you will need to put your decimal point in the correct spot, which will affect your exponent. Put your decimal in the correct spot, so it will affect your exponent. That's kind of a mouthful. And they've been having us practice that pretty much every day in the written practice. We've gone over it many times. So this should have given you plenty of time to put your supposed answer there. So okay, so first thing we can do is we can just take our numbers and we can multiply those. That'll get me there. And then we can take our exponents. So I guess I'll keep the dot. And add that together. So that'll get us there. Am I done?
No.
Goodness, no, because... Oh, wait, yes.
You could first 12 times 10 to the power of 11. 12 isn't proper because it has to be a number between 0 and like 10, so it has to be 1.2.
Okay, great. Yeah, my decimal's in the wrong spot yes?
Do the next step.
Yes. Okay. I'll throw in a little bit there. So I have now, and I'm gonna switch to an X here because I think that's kind of what scientific notation generally looks like. And so I have now divided this number by 10. So in order for me to have an equal expression here, I would need to go ahead and finish.
You would have to do it like 1.2 times 10 to the power of 1.
Oh no, not 10 to the power of 1. But you're very, very close. Just so I'm dividing it by 10 on this side. This is how many times I'm multiplying by 10. So I need to multiply by 10 one more time or one less time. Since I divided this by 10, I need to, and I'm multiplying this, in this one I'm multiplying it by 10 by 11. In order for it to be the same expression, for it to have the same value, I would need to multiply it by 10 how many times here? One more time or one less time? Ooh.
One more time.
Yeah, one more time, because I divided this by 10, so now I'm multiplying it by 10 over here one more time, so that this is an equal expression. Okay, well thank you for that though. That was some great participation. Alright, so same sort of thing here, except of course this time we're combining two negative values, but then we are also going to have to do the thing where we divide. Oh wait, no we don't. Never mind. That's the next one. Okay. Never mind. Okay, I'll give you one deep breath. This should be kind of a no-brainer. So, one deep breath. Yeah. Okay, you should be done by now. Alright, so 2 times 3 is 6. And then every time I see them do scientific notation, they use the X multiplication.
Yeah,
So
that's nicer.
okay, so I'm doing that, and then I'm combining my two negative values to get a value of negative 12, and we don't have any issues with the decimal, so we are done, and we are almost done with this lesson, so our friend here can get to a student council meeting. Okay, so all right, let's figure out this one. Now you're combining a value of positive 3 with a value of negative 8. Be careful of that one. So I'll give a... And this time you are also going to be dividing your number value in there by 10. But then you're going to have to think about, what do I do with the exponent? Okay, that should have given you time to figure it out. Okay, so 5 times 7 is 35. And yeah, I'm switching over to the X just because that's generally how I see scientific notation expressed. And then so combining a value of 3 and a value of negative 8 is going to get to what? Oh, well, just everyone should be able to tell you. Ready?
Negative 5.
Okay, good. So that's that. But I'm going to need to divide over here by 10. And remember, this means I'm dividing by 10 5 times, right? So, am I going to need to divide by 10 one more time or one less time in order for this to be an equal number? I mean, I'll let you have another try.
One less time.
One less time. Yes. Perfect. Okay, and that's the lesson. Pretty straightforward. Want to give me 1, 2, or 3? How do you feel? Okay, pretty good. Pretty good. Okay, okay, okay. Right on.
Every other